So what is trunking? Forming a trunk interface is trunking. Okay. So a trunk is a single channel of communication that allows multiple entities at one end to correspond with the correct entity at the other end. Means one VLAN, let's say you have one VLAN 10 on one side of the switch, and there is a second switch that also has VLAN 10. So they both should communicate. Similarly, VLAN 20 should communicate with VLAN 20, 30 should communicate with 30. So how this will happen? With the help of trunking. It is a link that carries many signals at the same time. Okay. It is a link that carries many signals at the same time, creating more efficient network access between two nodes. Okay. With VLAN trunking, it is possible to extend the VLAN across the network. What does it mean? Means, let's say you have a company. Okay. In your company, there are certain floors and they are having the switches. So if you're, let's say you have created VLAN 10 for your HR department. Okay. So some people from your HR, they are sitting on this floor. Let's say this is the ground floor, this is the first floor, and this is the second floor. So some people are sitting on the second floor. So you will have one VLAN 10 here. Now again, here also, VLAN 10 should be there because let's say few people are sitting here and few people are on the ground floor. So everywhere you require VLAN 10. Similarly, let's say sales department is also there. For sales department, you have created VLAN 20. Now you need VLAN 20 also. Let's say some people are here, some are here, and some are here. But we also want that all the HR department should communicate, all the sales department should communicate. So we will connect the switches. Correct. Now what? They need communication between them. So through this one interface, you will have to transfer VLAN 10 data also, 20 data also. Either you do this, or for each and every department, you use one extra link with the switch. These are the possibilities. But if you have multiple departments, then this is not possible. So we always go with the trunk. We'll create these interfaces trunk. And if you create these interfaces trunk, what will happen? Multiple VLAN data traffic will be able to pass through this switch or this link. This is clear. So you can see I can extend as much as I want. My VLAN, I can extend to every part of my network. Okay, with the help of trunking. So when you implement multiple VLANs across a network, trunk links are necessary to ensure that VLAN signals remain properly segregated for each to reach their intended destination. Now, VLAN 10 traffic will also pass through here only. VLAN 20 will also pass through here only. So these traffic should be segregated. And how they will be segregated? There is something called as a tag. So with the help of this tag, means on the packet, there will be an information attached that this belongs to VLAN 10, this belongs to VLAN 20. So with this tag, they will identify. This is also more efficient as multiple VLANs can be configured on a single port, because trunk port by default member of all the VLANs. So that means we can say that, okay, on that port, all the VLANs are configured. Okay. This is clear. Okay. Now for tagging purpose. Okay. There are two protocols. One is the ISL and second is the .1 queue. Your ISL protocol is a Cisco proprietary protocol. Okay, this is a Cisco proprietary protocol, but not even Cisco using it. Cisco is not using this protocol. By default, Cisco is preferring .1. This is the open standard protocol. Works on all vendors. Okay. So what happens? Your ISL protocol. ISL stands for inter-switch link. Okay. And this IEEE.1Q. 8.2.1Q. Okay. In short, we'll call it as a .1Q. Okay. So this .1Q protocol is better than your ISL. How? Your ISL protocol, it attaches 30 bytes of extra information with the packet. 26 bytes header, 4 byte trailer. But your .1Q adds only 4 bytes. Much better. You can carry more data in a frame. Okay. Then in the .1Q, we have a concept of native VLANs. Okay. Here all frames are tagged. all frames are tagged. But in case of .1 queue, there is a concept of native VLAN. Native VLAN is what? See, by default, what will happen? All the ports of your switch belongs to VLAN 1, right? So the switch already knows that, okay, everything is what? VLAN 1 only, right? So do I need to put up this information? That, okay, this is belonging to VLAN 1? No, right? I do not want to. So what it is doing here, the native VLAN frames are not tagged. Means it will not put up a tag for the packets that are by default belonging to native VLAN. So by default, your VLAN 1, it is known as default VLAN, correct? But it is also the native VLAN by default. It is also the native VLAN. So now everything is belonging to 1 only. So no need to put extra information that, okay, this is also belonging to 1 only, correct? So here native VLAN frames are not tagged. Okay. So what does it mean? So if a switch receives a frame, if there is a frame coming to a switch without any tag, so obviously that will belong to which VLAN? Native VLAN. By default VLAN 1. Okay, your native VLAN can be changed. You can manipulate your native VLAN. No problem. Okay. This is clear? Yes or no? So far clear? Okay. So by default, your Cisco is also choosing what? .1 queue protocol. Okay, see here. So this was the switch port acting as a. Now see here, which protocol they are using. .1 queue. So by default, they will use .1 queue. And what is the native VLAN by default? 1. Is that clear? There will be no tag. See, when the frame is outgoing, no tag will be put up on the frame. And if a frame is coming that is not having a tag, again, that will belong to native VLAN. And if it is belonging to a specific VLAN, then that will be passed to the specific VLAN. Okay. To save that 4 byte also, it attaches 4 bytes information. But even to save that also, they will not put up a tag for native VLAN. So that if the traffic is just for the native VLAN itself, then no need to use that 4 byte also. Okay. So extra 4 bytes, even that can be saved. So without any tag, the communication can happen. Is that clear? Now see, let me show you. Let's say this is PC. And let me set the IP address here. 10.0.0.1. Okay. I'll have one more switch and one more PC.
Okay, and both the switches native VLAN will be there.
By default, both the switch will have native VLAN.
Some ports native VLAN will be there.
On each port, native VLAN is configured by default. And by default, it is VLAN 1.
So the traffic belonging to the native VLAN travels between 2 switches. Then
No.
it will not be there.
Correct. Now see. See, here I have the IP 10.0.0.1. Here I have the IP 10.0.0. Okay. Now, by default, everything belongs to what? VLAN 1 only. See. So if I try to ping, what IP did I give here?
IP didn't configure yet.
Oh, IP not configured. Now you see. Okay, let's check the packets. We are pinging, so I will remove everything and we'll see just ICMP. This is the packet. By default, having layer 2 information, what is the header? Ethernet header. Correct. This is the normal header. Still normal headers, Ethernet only. Same thing. Okay. Now see, what I'll do, I'll configure VLANs here. I'll say VLAN 10. And this side also I'll say VLAN 10. Okay, I'm not assigning the membership. Okay, as of now, I'm not assigning the membership. Just created the VLANs. And let me create these interfaces as trunk interfaces so that multiple VLAN traffic can pass. So interface F0 by 2, right? Interface F0 by 2, switch port, mode, trunk. And this side also. Interface F0 by 2, switch port, mode, trunk. Done. Now see. These are trunk interfaces now. Now let me think. Still, this traffic will belong to the native VLAN only. Why? Because on F0 by 1, if you see the VLAN configuration, do show interface F0 by 1. Switch port. So if you see, still the native VLAN is what? 1. So this traffic belongs to native VLAN only. Still the frames will not be tagged. On see your PCs, your end host will never be aware of VLAN. Your PC, whatever end devices you are connecting, they will never be aware of VLAN, that which VLAN they are in. The VLAN concept is just for the switches, not for the end host. If you see here, see normal Ethernet header, correct? Why? Because this traffic belongs to native VLAN. Now what I will do, I will add these ports in the VLAN 10. Okay. Interface F0 by 1, switch port access VLAN 10. As soon as I added it in VLAN, you will see here that what is my access mode VLAN? What is my native VLAN? So means now this is not belonging to the VLAN 10 because now this port is member of VLAN 10. And earlier what was happening? Both are same. Okay. So now it is not belonging to the VLAN or the native VLAN. Correct. Now you will see the switch will put up the tag. Here also let's go. Interface F0 by 1, switch port access VLAN 10. Now check. Go to the PCs. Try to ping. Obviously, they have communication because they belong to the same VLAN. Okay. But if you check the traffic, as of now, normal Ethernet header, when it goes to the switch, now see, when the packet was incoming, it was having which header? Ethernet. But now, .1Q header. Now it will put up the tag. Why? Because this traffic is not for the native VLAN. Is that clear? Okay. So the switch who is sending the traffic will attach the tag. This switch, what it will do, it will remove the tag before sending to the this PC. Check. When the packet was incoming, it was having. Now will remove the tag. Okay. This is clear. Okay.